Morning. Thank you for having me. It's great to be here. This is a difficult topic for me. I started a few open source projects, and people now think I'm a visionary and think I can see the future, and it's not the way I worked. I've typically looked at facts and then guessed what to do next, but never tried to glance too far out and make any bold predictions. And so the fact is, I can't see the future. I don't have a time machine. So I was worried about, how am I going to give this talk? How am I going to, people want to hear me talk about the future. What should I do? And then I realized one morning a solution to this, that a lot of facts contain within them predictions about the future. For example, if you consider a rocket flying, if you know its position, you know which way it's pointing, you know how fast it's going, you can predict where it will land. You can't be certain where it'll land. Could hit an asteroid, but you've got enough confidence that you're probably willing to make plans around it. If it's got people on board it, then you try to go meet them. If it's got a bomb on the front, you'll try to get out of the way or intercept it or something. So in that style, what I'd like to try to do is look at some facts about data and see what we can find in them in terms of predictions about the future. So let's start off with an easy one. For close to 50 years now, we've seen this phenomenal improvement in the capabilities of computing hardware. Processors have gotten faster and cheaper. Memory has gotten more affordable and bigger. Hard drives have gotten considerably larger. Networks have gotten faster. Just about every dimension of computing, we've seen dramatic exponential improvement for decades. Just really phenomenal. You don't see this in other technologies. I can't think of any other area where we've seen anything like this. We sort of take it for granted, but it's it may not go forever, but I'd be hesitant to predict that it's going to stop tomorrow. So what does this mean for data? Well, I think we can safely say that in the future, you'll be able to store and process even more data than you can today. So what are we going to do with this data? Why do we care about data? Well, data is incredibly valuable. Driving, in fact, in many ways, this improvement in hardware has been our use of computing devices throughout industries. Cash registers, hospital beds, tractors, jet engines, trains, trucks, you name it. Just about everything out there today gathers or generates data as it goes about doing its business. And this data, if we gather it and inspect it, can give us a picture of these businesses, where they're succeeding, where they can be improved. It's a very high-resolution image. And if we have these pictures of ourselves, we can go about improving ourselves. Without them, we're operating blindly. So data is tremendously valuable. How can we take advantage of this? What's the missing piece? Well, we need some software. In the past, software was predominantly something that was licensed. You paid a fee again and again, oftentimes for the same software. And a lot of people came away from this not particularly liking the scenario. They built their business with some software at its center from a proprietary vendor. And over time, the price of that software goes up, and their whole business is subject to the whims of some other company, which is not a great situation. And I think people have grown wary of falling into this trap again, and have started flocking to open source, where they can use the software without paying any fees. If they get services from a vendor, then they can pay for the value received each year. And if they decide they don't like that vendor, they can switch to another vendor without changing the software platform that they're using. So here, the prediction I think we can make is that in the future, platforms for data must be built on open source software. That's what people are demanding these days. All new platforms, from Linux to Android, tend to be open source these days. So what sort of open source software do we need? About 8 years ago, I started working on a project called Hadoop, where we were trying to build a scalable, flexible platform for computing. Needs to be scalable because we want to be able to import arbitrary amounts of data and process them. Flexible, we want to be able to use a lot of different types of processing on them, on the data set. Initially, there were a lot of limitations to Hadoop. It wasn't even really that scalable or flexible. It ran on maybe 20 machines and supported MapReduce for Java programmers. It was still useful. After a couple of years, it really got to be quite scalable. Would run on thousands of machines. People were running it over petabytes of data. And over time, more and more of these limitations were removed. Initially, it wasn't very secure. If you had different groups who needed to share a cluster, but didn't necessarily want to share all their data with one another, that didn't work well. We've addressed that. Security is now well supported within the Hadoop system. There was a single point of failure that led to availability problems. And if people wanted to have a system that was up 24/7, this was a problem. That's been addressed. Again and again, we've seen problems in Hadoop fixed. And it's gotten better and better through the years. So what prediction then can we make about Hadoop? I think it's safe to say that it will be and is a foundation for data systems that is secure, reliable, scalable, flexible. So what's happened around Hadoop? We've seen a huge number of projects added around Hadoop that are really addressing the flexibility issue. Whereas the core provides this batch programming metaphor in MapReduce, which is useful in a lot of cases when you need to do a massive analysis of a data set. There's a lot of other use cases. And we've seen these addressed outside of the Hadoop core by other projects. First, there were things that built on top of the batch capability. We saw the PIG data flow language, which emits MapReduce jobs. Hive, originally from Facebook, implementing SQL on top of MapReduce. We've also started to see things that aren't batch-based. HBase, modeled after Google's Bigtable, gives you an online key value store so that people who have online systems where they need to do lookups and store data in real time could now do bring this kind of workload to Hadoop. Also seen interactive SQL recently added to the stack with Cloudera Impala. And this last year, search. So everyone's familiar with doing searches on Google and lots of commerce sites. And now they can bring that familiarity to searching their enterprise's data in Hadoop. So the prediction I think we can make about the future is that we'll see more and more types of workloads be able to move to Hadoop. For example, we expect to soon see good support for streaming, for in-memory databases, for graph processing, and so on. So where does this place Hadoop? When we first started on the project, it was just a tool we needed to process the data sets we had. And I fully expected other people to provide alternate tools providing similar functionality, that there would be some competition, but that really didn't happen. There really seems to be one primary system in the big data sphere that's providing this general purpose platform. Hadoop's effectively becoming a kernel of an operating system for big data. Over time, more and more workloads are moving to this. The things that were out in silos are gradually, the silos are atrophying, and the workloads are moving to this hub for enterprise data on Hadoop. And it's quite a phenomenal trend that we've seen over the past 4 years or so. And it really seems inevitable that this is becoming the standard place where enterprises will put data in the future. Seems like a safe prediction. So how far can we go with this? To my thinking, the sky's the limit. It's hard to imagine workloads which you can't bring to Hadoop. Google, a few years ago, needed to do online transactions. They needed to do their sales systems, and they wanted to deploy it on a Hadoop-like architecture, and they built a system called Spanner, which they wrote about. This is a tricky problem. It's one that many people didn't think would be possible on this style of platform ever. If you've got, if you're doing a sale, then you need to move money from one place to another, and you need to adjust inventories. You need to do all these things in a coordinated manner. You need to make sure that the money's in one place or the other, but not both and not neither. And you need to do this interactively in an online manner. This is, OLTP, online transaction processing. I think even this, given that Google's provided this an existence proof, can move to the Hadoop platform. So the prediction here is clear that if somebody's demonstrated that it can be done, it's inevitable that it will be added to this platform because it brings utility. The more you can bring your computation to your data, the less you can move your data, the more effective your system will be. That's the moral we've seen again and again, that moving computation is much easier than moving data. And having your data in a single repository where it can be shared. And you can effectively share data, not just data, but share the hardware resources as well. Your two big investments can be maximized when you use a system like Hadoop. So at the outset, I wasn't sure that I could make a prediction. Here I've made a reasonably bold one. Got lucky. It seems to me that in general, the future for data is Hadoop. Hadoop is emerging as the hub for enterprise data. New workloads are moving to Hadoop all the time. From analytics, data warehousing, search, all these things are coming together in this one platform. Now, we're in sort of a revolution in data processing. Things are changing very, very quickly. And a revolution is kind of a scary time. You may not be sure what are the right bets to make. What technologies do you want to build your business around and become reliant on? And I think you can be comfortable adopting Hadoop at the core of your data systems now and for the future. Thank you.